All right, let's take a look at how to find distances between points. Again, you've seen how to work with number line distances. Do you remember what algebraic operation gives you distance from zero or distance between two things? Yes, it's the absolute value. Good. All right, so absolute value. So if I go from -3 to -2, I've moved a distance of 1. To compute that algebraically, then you can do, since -3 is smaller than -2, you take the bigger number minus the smaller number, and that will give you 1. Or you can just take either of the two numbers and subtract, and just make sure that you have absolute value to make sure that the distance is always positive. So absolute value between the difference of the 2 points gives you distance between them. So what if you have a point -3 and a point 4? What do you think is the distance between them? Again, you can do absolute value, or in this case, you can actually subtract the smaller number from the bigger number, giving you the distance between them is 7. Generically, then, if you have 2 points at A and B, how do I get that? I can do B minus A, or I can say absolute value A minus B. Either way, it's going to turn out to be the same positive number, distance between them. Another way to think of absolute value, now that you know how to work with radicals, is square root A minus B squared. Just keep that in mind when we extend to two-dimensional space. So in general, if you have two real numbers A and B on a number line, and the number line on the number line, so again, formally then, the distance between any two real numbers A and B is given by absolute value A minus B, which is the same as square root A minus B bracket squared. So playing would involve, how do we extend this to the Cartesian coordinate system? All right, so here we are. Let's put a point 2, 3, and we'll go sideways this much amount, vertically that much amount to go to the second point, 6, 10. And I want to know how to get distance between 2, 3 and 6, 10. So that would be the length of this red line segment. Well, you can see we have formed a right triangle here, and many of you might remember what to do next. We know that this distance is 7, this distance is 4, because we know how to compute distance just on the number line. So if you wanted to distance from 2 to 6, 6 minus 2, or absolute value 6 minus 2, which will be 4, and absolute value 10 minus 3 is 7. To get this, then we can use Pythagorean Theorem. So that will be square of each of the legs here added together. Square root will give you the hypotenuse, right? In a right triangle, a squared plus b squared equals c squared. That's what most people remember as Pythagorean Theorem. So that's how you would compute distance. All right, let's take a look at these 2 points. How do you think we can compute distance between those? So from here to here would be -2 minus -5, which is 3. From here to here would be 5 minus -1, so 6. And so the distance here will be 3 squared plus 6 squared, square root 45. Always remember, whatever answer you get, write it in the simplest form, reduced form. 45 is 9 times 5. Square root 9 is 3, so square root 45 will be reduced as 3 square root 5. Don't forget to do that one last step. So in general, then, distance formula should be just computing the, using the Pythagorean theorem. So do you remember, some of you, we always look, So before we formally write down how to find distance between given any 2 points in the coordinate plane, let's just quick review in case some of you do not know the Pythagorean theorem. The Pythagorean theorem says that in a right triangle, the length of the hypotenuse squared is the sum of the squares of each of the leg lengths. Sometimes mathematical proofs are difficult to see, but this is one proof that is so beautiful. I know you may not all think that, but I think it's really beautiful because no words are necessary. So I'm not going to speak. I'm just going to display the theorem, and see if it makes sense to you, and then I will go through the proof so that you understand. All right, so we start with a square a plus b long. Here's the second square a plus b long. So both sides are a plus b. So if this is a and this is b, this is a and this is b right here. So what we're doing now is we have two squares and we're taking out chunks of that square out. All right, so let's just imagine this orange region is now cut out. This area left over is the same as this area left over. Does that make sense? Because we started with the same area, so if you remove the same amounts, whatever is left should also be the same. Let's do the same here. Take the green triangle out. Again, it's a by b here. Take the red rectangle from both out. So if you keep doing that, then the leftover area here is c squared, leftover area here is a squared, here is b squared. So these two areas added together should be equal to this area here. How do I know? Well, these two you can see they are squares. How do I know this is a square? So you might need a little more explanation for why this is a square, why you should expect it to be a square. This is a right angle right here. And you also know that all angles in a triangle add up to 180. So that angle here plus that angle here add up to 90. And these four triangles are congruent to each other. So this angle is the same as that angle. This angle is the same as that angle. Those two add up to 90. So these two add up to 90. The angle here is 180 because it forms a line. And so that means that this angle is 90. And you can show that all angles are 90. They all are of the same length because they are the hypotenuse of the same right triangle. And so it's c by c squared. So there is c squared should equal a squared plus b squared. So this is called a visual proof. All right, so what did we just do? We said distance between 2 points. So it's x1, y1, and x2, y2 are our 2 points. And we want to know what's the distance between them. So this distance, do you remember how to do that? So that would be x2 minus x1, y2 minus y1, and the distance would be the square root of that. So distance between any two generic points is given by square root of the difference squared in the x direction, difference of the y direction squared, added together square root using the Pythagorean theorem. And you can see that if you were to hide this y part, then it is the same as distance on a real number line. So what do you think will happen if you extend it to 3-dimensional? You just have to add one more component of difference of the z coordinate squared and just extend the root over it. So you can see there is a symmetry when you go from 1 to 2 to 3 dimensions in some of these ideas. So this is what we've so far seen. Distance between two real numbers on the number line is given by that. Distance between 2 points in coordinate plane is given by that. 3-dimensional space distance will be given by that. You know, there is a field of mathematics called the real analysis and also a field called topology in which people study different ways in how you can work with distances. They're called metrics, and they satisfy certain properties in order for them to be called the distance or metric. You can read the book for further explanation of what I'm talking about. Try these on your own. All right, so one thing we can do is look for applications of distance formula. We're going to use it to find equation of a circle. Let's start with a circle where the center of the circle is 7, 2, and the radius is 5. So we want a circle is defined as all points that are equidistant from a fixed point This fixed point is called the center, and this fixed distance is called the radius. So if I want all points that are equidistant, they would have to go all the way around 5, around 7, 2. So everywhere you move, so again, let's take a look. You're going all the way around every time, keeping distance of 5 from this point 7, 2. So here's what will come, right? This is what the path was traversed by this point xy. So let's say I have a point xy here. How do I know if these points are on the circle or not? I would only know that if I were to look at the distance from here to here and say that that distance is 5, which is the radius. You already know how to compute distance. This is x minus 7, this is y minus 2. And so if you took distance between 2 points, it should equal 5. Or you can just to remove the square root, square both sides, and you'll end up with this as an equation. So which is, it's not quite true to just say square root x minus 7 squared plus y minus 2 squared equals 5. That would not represent the whole circle. That would only represent the upper half of the circle. To get the y coordinates underneath, you'll have to have a negative square root. So we can just square both sides, and this will give us all the points on the circle. So it's an application of distance formula. Okay? All right. So in generic terms then, if you have center is hk, and xy is a point on the circle, and the radius is r, then x minus h squared plus y minus k squared equals the radius squared using the Pythagorean theorem.